So this is the previous system that we had before, and I'm going to wake up this meter here set to amperes, okay? And so there's really only 2 meters here now because the power supply is just 2 older 12-volt lead acid batteries for motorcycles, and this red lead here is just connecting the negative of the right battery to the positive of the left battery. The negative of the left battery is actually going into the ammeter function set for 10 amps on the small black meter, and then the black lead is in turn returned to the negative terminal of the second battery. So the larger meter, it's basically across the output voltage of the 2 batteries, and it's currently showing at 22.8 volts, which means that we've drawn some current off this guy. And so I'm going to have to charge these batteries probably for a few hours to get them back up. But the batteries, I didn't know if they were any good, but they actually hold their charge pretty well, and there's a lot of ampere hours in here because, as you'll see, we're going to draw a lot of amperes. So the point of this demonstration is just to show you what size arc you can pull. So the gray wire, which is the negative of the flyback, is going to be presented to the suction cup positive here, and we're going to draw a serious arc. And when we do that, we're going to see a big jump in the current draw for the so now this is quite an arc, and let me see if I can get this in a better view here. Oh, I'll just move myself. How's that? And I've stripped the wire back a little bit, so where is that? So I'll burn the copper, but I won't burn the insulation. So let's draw it now. You have to get close to start. So it looks like you have to be a good, centimeter and a half away to start. But once you start and you ionize the air, you can get an arc length on the order of, what would you say that is? I don't know if you saw that here. Let me do this again. So that distance there to the terminal, so the initial distance is about a centimeter. Oh, it's getting pretty hot. It's burning the wire and burning the insulation too, but no danger as long as you hold it with the chicken stick here. So this is the chicken stick, by the way. That's me, I'm a chicken. So the arc drawn is probably 2 to 3 centimeters. Now you'll see over here, the battery voltage is still at 22.7, and the board is, when not drawing an arc, is drawing what we had with the ExTech voltage power supply, about 560 milliamps. But when I draw this arc, it goes up to 7, maybe 8, 7.8. So that is a serious voltage. But it seems to me the voltage actually is about 22,000 volts, even though the arc length is about 20 millimeters. So that would seem to imply that the rule of thumb of 1 kilovolt per millimeter is correct. So the way to stop this safely is to remove the negative lead and therefore defeat the power supply of the battery. You can see here that the 2 meters are 0, but there's still a possibility of charge stored in the capacitors of the ZVS board. So if you listen carefully, you probably hear a clicking sound here. Yeah, there was a clicking. I don't know if you heard that, a clicking sound. So that means there was something that was still in the ZVS board. So you wouldn't want to be touching this board here with your hand until you actually made sure that the board was properly discharged. Okay, so this is just a regular demo the 12-volt battery without any kind of control device for the batteries itself. Now, in another video, I'll try to put a control device on here and see if I can actually change the voltage from the battery to the ZVS board. The unit I'm going to use has a rheostat on it, and it nominally can handle upwards of 30 amps, but it's a PWM board, so whether a PWM voltage will be usable with the ZVS board is unclear, so that's to be determined.